Uranium is a very heavy metal that can be used as an abundant source of energy. It is found in most of rocks, and it also occurs in seawater. It was discovered in 1789 by Martin Klaproth, a German chemist in a mineral called pitch rendered. It was named after the planet Uranus. It has a chemical symbol U, the proton number is 92, and the mass number is 238. Uranium has high density and high melting point of 132 degrees Celsius. It has two isotopes such as U-238 and U-235. Today, its slow radioactive decay causes convection and continental drift as it provides the main source of heat inside the Earth. Uranium has several uses such as nuclear power, as a target for X-ray productions, as a material for some types of military weapons, gyroscope of international guidance systems. Uranium compounds had been used for centuries to color glass. Uranium trioxide has been used in making of Piesta work plates. Uranium is used in making of atomic bombs. Depleted uranium, which is used for tank, armors, and to make bullets. Uranium resources can be extracted from the ground in three ways. First one, open with mining. It is called strip mining, so physical soil and uneconomic rocks will be removed together. This type of mining is possible if the uranium is near the surface, which is normally less than 400 feet. A series of the branches of staff are cut into it to remove the ore easily. Depending on the size of the mine, there might be one or more rolls cut into the sides of the pits so that the ore harvest can go through the area easily. Pumps might be used in order to remove the water from the pit. Second one, underground mining. It is called underground mining. It is used to get a higher concentration of uranium, which is found very deep under the ground. The ore is drilled then down to the created debris and then transferred to the surface, then onto the mill. Third one, in situ leach, ISL. It is preferred method to extract uranium since it is far cheaper to get the ores out of the ground, and it is considered more environmentally friendly than traditional underground or open pit mines. Pumping water from the formations and adding oxygen such as gaseous oxygen. With some units of carbonate phases such as the sodium is added to the solution to make it easier for uranium to go into the solution. Ideally, the pH of the solution is somewhere between 6.5 to 7. This solution oxidizes the uranium in porous sandstone and makes it easier to go into solution. The oxygen-rich solution is pumped down injection well within a well-filled pattern. The solution moves through the rocks, dissolving the uranium in the ground. Well, at prescribed distance from the injection well pump uranium and rich waters to the surface. Recycled uranium has a number of advantages. A saving of 25% in the use of natural resources, a reduction in the volume of waste by the factor of 5, and a reduction in toxicity by a factor of 10. A reduction in the proliferations of nuclear materials, a reduction in the quantity and radioactivity of the end of waste. There are three ways to recycle the uranium. First one, once to recycle. The simplest to recycle is once to recycle. It is the de facto standard in most operating nuclear power plants, with a few exceptions in Europe and Asia. Uranium is mined, enriched using a reactor, and then stored until it is no longer dangerously radioactive. While the cycle is cheap, There are two major problems with it. Firstly, the waste is radioactive for hundreds of thousands of years. No one has been able to design the laboratory that is convincingly capable of storing materials for that long. Secondly, uranium is not the most abundant element on Earth, and in its kind of cycle, the global supply of cheap uranium could run low within 200 years. The second one, closed fuel cycle. Closing the fuel cycle involves recycling the nuclear waste as a new fuel. Since the main component of nuclear waste is uranium-238, we can get more energy out of the waste than in the ones recycled. The recycling plant separates the good stuff from the bad stuff. The bad stuff is mostly fission products, the atoms that are uranium atoms became after it splits in the fission process. These fission products mostly decay to save labors within 300 years to 500 years, which is shorter than standard nuclear waste. So, by closing the fuel cycle with standard reactors, we address the issue of nuclear waste identified in the 1-2 cycles. In this case, nuclear waste is a tractable problem, but most of the reactivity is coming from the mine, since standard reactors burn most of the fission nuclide U-235. The third one, Blooded fuel cycle. Blooded reactors can create as much or more fission material than they use. These special reactors are designed to have extra nutrients flying around, so that some can convert U-238 to Pu-239 and the others can run the reactor. Often the special reactors are dimmed fast reactors because the nutrients are moving through the reactors at higher speeds on average. In a full breeder fuel cycle, we get the maximum use of the proliferations concern associated with any closed cycle. Additionally, we have less operational experience with breeder reactors, so we would need to train breeders and operators for such a machine. Using a cycle instead of uranium-plutonium cycle may allow breeding in less extended reactors. Using this kind of fuel cycle, nuclear power can truly be considered sustainable. The advantages of recycling uraniums. 1. It saves 25% the use of natural resources. 2. It reduces the volume of waste by the factor of 5. 3. It reduces the toxicity by a factor of 10. 4. It reduces the proliferations of nuclear materials. 5. It reduces the quantity and radioactivity of the end of waste. 6. It reduces a lot of energy. For example, one uranium pellet can provide the same amount of energy as 548 liters of fuel. 7. The uranium fuel lasts long and doesn't cool too much at high temperature. Disadvantages of recycling uranium. 1. It produces nuclear waste, which is extremely radioactive, toxic, hot, and dangerous. 2. Only 98% of the fuel can be recycled and used again, and 2% is waste. 3. It produces another element once the uranium is used in a reactor. These are stored in a large swimming pool to allow it to cool down, and it's radioactive to decay. 4. For example, The open to recycle is the cheapest way to recycle uranium. However, the nuclear waste is radioactive for hundreds of thousands of years, so no one has able to design the liquid facility that is capable of storing nuclear waste for that long period of time. 5. Recycling uranium is not suitable because uranium is not most abundant element on Earth, which this global supply of cheap uranium might only last for about 200 years. 6. In the case of closed fuel cycle, the reprocessing technology is too expensive and separates out poor plutonium, which could possibly be stolen in order to make a nuclear weapon. Uranium interacts with the environment. 1. Nuclear power is not carbon-free. Nuclear power does not save the climate because it covers slightly more than 2% of global energy consumption. Nuclear power is bigger energy wastage. Nuclear power plants are profitable only if they are operated continuously. At night, however, less electricity is needed. 3. Nuclear waste remains radiating threat for a million years. Implication of solution for uranium compared with aluminum. Based on my research, I think recycling uranium is less effective when compared to recycling aluminum, as it takes hundreds of thousands of years for the nuclear waste to decay that requires a very good repository area, and the reprocessing technology is very expensive. Plus, only 98% of the nuclear fuel can be recycled and 2% is waste. However, recycling aluminum provides many environmental, economic, and community benefits. It saves energy, time, money, and precious natural resources. Also, it generates jobs and helps to pay for community service that make life better for millions of people.